Good morning, everybody. It's a beautiful morning here. I wish we all are having a great time out there, wherever we are. Wishing us the very best. Last time, we introduced ourselves to R. We've gotten ourselves familiar with the various panes in R Studio. We've talked about the scripts pane where we write our scripts. We talk about the console. There is the console. Talk about this particular lower right hand side and the upper right hand side. Here we've talked about the various tabs we have here: files, talk about plots, the package, and all the rest. We've talked about how we can load packages that we need for our work, and how we can load in our file. For example, let me quickly run over the way we can import our data sets from where we have it. Now, there are two ways I will just show us here, though I showed us only one the last time or in the last video. The one I showed us is we're going to this place, file. Once we get to file, scroll down to this import data sets. If our data set is in form of Excel, we click Excel, then we can browse to the location of our data. Let's say, for example, I want to load in this Africa virus file. I will click it, then it will take me down to this window again and giving me a view of what my data sets look like, and I can finally click imports. Once that is done, you can see my data set is in R, and if you can come here, you will see that it saved that data set as Africa virus. That is the name it used to save my data set. That's because that's the name I use in saving it there. But I've told us if you want to change the name, we can use our up arrow to go up there. Once you go up there, now use your backward arrow to go to the place, change it to the name you want, and once that is done, you have your data set saved in your choice name. So that's that. Now another way we can import our data set. Let me close this tab. Another way we can import our data set is coming to this tab. Let's take for example that when you came here, the files tab is not active. It's not active. Just ensure you click the file tab. Once you click the file tab, you can now search. You can scroll through here to look at the data you want to import. You scroll through it to see the data you want to import. Let's say, for example, you can see this is the Africa virus I imported initially. Once I click it, I said import data sets. You can see it. I can view the file and I can import it. I'm interested in importing it, but you may want to view it to see what it look like first, and if that's what you want, you click view. Once you click view, it will bring it up for you, but let's import it. I click import. You can see it. This is it. Once I get here, it bring up, rather than me going through one by one what I did the other time, you can just bring it with just a single click. I click import and I have my data set. Okay, that said, we won't be using a specific data set unique to us, but I've tried to do this so that if peradventure as you are going through you want to use your own personal data to practice, so that you can know how you can import it and start practicing with your data set. However, one thing you must do to be able to follow what I'm doing using your own data is that once you import your data set, for example, let's say you import it, um, you import your data set the way we've described. Make sure that you change it to a data frame. Change it to a data frame, because if you don't change to the data frame and you have imported in any other format unknown to you, you may not be able to subset or to do some of the things that we will be doing. So how do you change it to data frame? Say for example the name of your data. Let's assume that what you have done, you have used my data. You have changed, you use my data to save that data set that you've imported. You now just say my data is what? As data dot frame. Can you see data dot frame? You now open bracket, then enter the name of that your my data. Mind you, initially you have saved as my data, so you enter it again as my data, as my data. Once you do that, hit enter. It's showing me error. Why? Because there is nothing like my data at the moment. That is the reason it's showing me error. But let's assume I want to take Africa virus, for example, which I already have. I already have it. I already have Africa virus. Let's say I'm taking Africa virus. I will say, okay, as data dot frame. What I'm telling is that that Africa virus that you have saved, that you have imported, that is inside your memory, I want it to be as a data frame. I don't want it to be as a table or as a matrix or as a array, anything. What I want it to be as is data frame. That is what you are telling R. So I just put Africa virus. See, you can click enter. It has it as data frame. And once you've done this, then some of the things you'll be doing, you can replicate that on your own data set. You can follow now. Okay, now before also I've shown us that because we want to use a uniform data set for all of us, that's why I'm using data set that is installed, that is already in R, rather than using your own personal data set or my own personal data set. This is just to ensure that you followed easily. So let's assume that your data set is women. In R, there's a data set that's talk about women, which consists of the weight and height. So this is just to recap some of the things we've done. Okay, so I type that women. I've told us some of the things that you can quickly do. For example, want to have a summary of your data. You want to have a summary of it, see what it looks like. You just type summary. Once you type summary, you can see that even before I finish typing it, I would have suggested it for me. Summary women, hit my enter, it give me the summary. I want to see the structure. For example, let's see the structure of the Africa virus that we imported or just saved. I see structure, hit enter. It's giving me is it a data frame. It contains this, it contains that. So we've talked about how we look at the dimension. We talk about the structure, the mean. That then at least we stopped at around this plots. So how we plotted the women, the data set in the women, because it just contained two data sets. It gave us what we asked. Then we try to see if, assuming you want to add a title to it. That's what we do. We did that. Okay, let's say we want to change the color of this our point to black, to blue instead of black. We did that. You can see we just specify main, we specify the color and all the rest. We talk about as we want to save, have our data saved directly to a particular place. We said that. Now let's continue today. Let's look at histogram. If you want to plot histogram, how do you go about histogram in R, in base R, not just R, because we have various packages that we can use for histogram, but here we are maintaining base R. That's the basic one in R. The function is ist. Once you say ist, now tell us what the data set you want to plot the histogram for. Like in the women now, we want to use the weights. So the title, the name of our data is saved as we men. Now for us to subset the weights, that the portion we need is the weight. The field we need is the weight, not the height. What do? We use dollar sign. Once we use the dollar sign, we click the weight, we click enter. You can see that's our histogram in R. But you can see in this our histogram, look at the title it gave us. It's a histogram of women. No, this is not a good title. The same thing, look at the label of x-axis. This is not a good one. We can specify that in our chart. How do we do that? It's a histogram, women height, main. You want to give it a title. Make sure it's in inverted comma. Title, weight of women. Okay, we want to specify our s-axis. We say x lab equals, we say weight, kilogram. This is all dependent on you. Once we do that, we can hit enter, and you can see our new histogram now. So that is how we plot histogram in R. So the same thing, let's assume now we want to specify, give it a particular color or range of color. How do we do that? We say ist. I've told us how to export our data sets for our file, our plots in the last class. Okay, we said ist women subset the weight. I said give me the color. The way I want to color it, I want to use a particular color called rainbow. Now rainbow is a set of color, it's not a single color. So I want to use a single, the range of color in rainbow. But in using that color in rainbow, I have to specify the length of the colors I want. The length, because rainbow is not a single color. So I have to determine, I have to tell it that okay, in the color you are using, this is the length of it. But if what the kind of color, let's say for example I want to use blue, like we saw blue the other time, I will just type the blue and that. But I want to make it a bit beautiful, so use different colors. I say rainbow. I will not tell it the length should be what now? Use the length of the data set I'm using, women height. I hope you have followed. Remember, I've told you before that for every opened bracket, there must be a corresponding closing bracket. And when you are using a function in R, a function working on an object, that object will be in brackets. So you can see here, this women weight here is the object. for this length, but all of them together are the object for this rainbow. So note that. Okay, now I can now give it that the main, if I want to give it a title, weight of women. Okay, let me hit enter. You can see the various color of rainbow. Remember, I didn't specify my X lab. That's why this. If I had specified my X lab, that X lab equals width in kg. So you can see that now. Okay, so let's go on. That is how you do your your what now? Your histogram. Let's go to pie chart. Now, in constructing pie charts, definitely know our data set should not be too long, like we have in the women. It is quite a bit long. So for that reason, I created a pseudo data set, which is what you can see here. I created states. I said the states I want. I said stated it there. Cases, I stated it there. I now told it okay. Save this now together. Concatenate it together as case data. So let me run all this together. Now what he has done, he has created, if I enter state here now, you will see what it will spew out for me. It will spew out for me, you know, all what I've entered up here as Lagos, Ogun, Oyo, Delta, Enugu, and Kaduna. Let me enter cases. It give me what did I store in cases. You can see it has given me the cases. Now remember, I've created a new data frame now, which is called cases data. Let me show you. You are giving me cases data. Let me see what cases data looks like. You can see it. I brought them together. Now I want to plot a pie chart for this. Now what is the function to plot a pie chart? It's just pie. Also say pie. You enter your what you want to plot there. For example, I will enter the cases, which is numeric, because for you to plot a pie chart, you need a numeric variable. So the cases, which is numeric. Now, how do I want to label it? I want to label it the states. The states will be in the label. Okay, let it enter. You can see what is giving us. Though this is not too beautiful, but for now, let's manage it that way. Now, let's assume that what we are doing is already in data frame format. We want to subset in data frame. Rather than here, we declare states separately initially and cases separately initially, and that's how we entered it this way. But let's take, for example, that what you have already done you imported your data frame, and that is what you want to plot. You say pie, you now enter the name of your data frame, which is cases data. We now subset our cases, and now tell it also that the label should be what? Cases what states. You can see we have the same thing. The same thing is what we're going to have. Okay, let's assume we want to change our color sets. We want to make it a little bit more beautiful. Let's say, okay, I can say pie. I'm not of typing it again. I'll just use my up arrow to go up there. Okay, going up there, I can say I want the radius, I want the radius to be +1. The radius can be between the range of -1 and +1. Just even though you didn't put the plus, just ordinary 1 is okay. I can put the title. If I want to put, just remember the title, how you put the title is using main equal this let me say distribution across states, distribution across states. Okay, let me say I want to give it different color. Let's remember, let's use our rainbow again, just to see, to use beautiful color. The length should be what, our the no length of cases. So cases, data set, subset what, cases. With that, we are good to go. Look at our new pie charts. Beautiful, beautiful. You can see it. So that's how you plot a pie chart. Let's go ahead. Let's see to plot a 3D pie chart. For example, I want to plot a 3D pie chart. Now, if you want to plot a 3D pie chart, there's a package that you need that is not in base R. I'm just giving us this as extra. A package, we call the package plots risk. Plots risk. Now, if it's not in your system, what you will do, you have to install it first. Now, how do we know? Let's come to packages here. You come here, click on packages. Let's search for plot risk here. This is where you can search for it to know whether, because it is too many, you may not get it easily scrolling through. Let's say plot risk. Now I have it myself. I have it already myself, so I don't need to install. If I don't have it, what would I do? I will, if I mean nothing came up here, I will just come here. I click install, and I will click plot risk, and with that I click install, and it will install the plot risk for me. But I already have it. So what do I do to load it? I just click this check beside it there. So with that, I have loaded it. So you can see, rather than me typing library plot risk myself, RStudio has entered it for me because I've checked it here. Now, to plot our 3D pie chart, use pie 3D. That is the function for plotting 3D pie charts. Okay, let's go now. Let's give it our let's give it the arguments. Say cases is what we want you to plot there. What do you want you to put as label? You say labels should be say labels equals states. Okay, Excel explode. We want to see okay, we'll use various values of explode for us to see the functions, what that explode is doing in our code. Okay, main, I want to give it a title. I say pie charts, for example, pie charts of infections. Okay, with that I click enter. Look at it. Look at my pie chart. You can see it is beautiful. It is beautiful. Okay, let me go up. I say, for example, let me change this explode from 0.1 to 0.4, and let's see what will be observed for you to know the function of that explode. You can see, look at the distance, how far apart these slices are, each of this sector. You can see now how far apart they are. Let's go back to the initial pie charts. This is the initial one, you can see it, and this is the new one. Okay, that's our pie chart. Let's go to bar plot. Now in our bar plot, I want to use another data set, called toots. The data set I could have used that will make you appreciate things better, but I want us to have uniform things so that we can lay our hands on it, then use our own data set to try our hands on these things. So you want to enter a data set from base R and save that data set as toots. That is what we're doing here. If you want to do it, if you don't want to use the script, the data set, you're just telling R that I want the data set inside of you. That's what I want to use. I'm not using this, so you can see toots growth. Okay, you will find when I tell it now to give me what tooth is, you can see it will list out everything. We don't need to be doing this because it will clutter your console. You can see how long it is, and if you have 50,000 data set, that's how it will load, bring out everything for you that way. So I can just use summary tooth to have idea of what I have in my tooth. It give it to me. Use dim tooth, it give it to me. I use structure to bring it to me. I use depending on what I want, it will give it to me. Now the tools I've explained to us in the class initially what this work tooth is about. Now if there's a cell called odontoblast. Odontoblast is responsible for the growth of teeth. Now an experiment was conducted to see if vitamin C has any effect on the growth of teeth. So guinea pigs were used. 60 guinea pigs were used, and they were divided into various groups. Now a particular group was administered 0.5 milligram per kilogram, 0.5 milligram of vitamin C per day. Another group was administered 1.0 milligram of vitamin C per day, while the last group, the third group, was administered 2.0 milligram of vitamin C per day. Now that's done. They wanted to check further again. Does the mode of administration, the mode of delivery of this vitamin C, does it have any effect also? So they now use two different types or two different modes of delivery. They used orange juice, and they also use just vitamin C direct. So that's why we have three columns. So you can see the length column is telling us the length of the odontoblast. Now this sub is telling us whether it was vitamin C that was administered directly or whether it was in form of orange juice. That's what's the other vitamin C, the sub is showing us. You can see we have OJ. Then here you can see the dose. We have 3 doses. We have one of them 0.5 milligram per kg per day. We have 1.0 milligram per kg. Then we have 2 milligram per kilogram body weight for each of the guinea pigs. Now for us to construct our bar plots, we say bar plot dose. Bar plot dose. The reason we did that is because we have used. Now one thing you should know, for you to construct a bar plot, you will be constructing a contingency table. A contingency table is to give us the frequency of each of the data set you want to construct the bar plot for. No, the bar plot is telling us, okay, for this particular object, this is the number of things you have. This one, so that is what we are looking at. We're not looking at the value of each of them. We're looking at the frequency of each of them. Now, to do that, we have to first of all do a contingent, construct a contingency table. And the contingency table for those, I said table. So for you to construct a contingency table, just use the function table. Once you say table, your data sets, if it is just one of them you want to use, you say that's your data set, you give it the table. Let's say tooth, those. If I enter now, this is what is giving me that for 0.5 milligram we have 20 there, for 1.0 milligram we have 20 there, for 2.0 milligram we have 20 there. That is what this is telling me. Now let me do another table. Say table. I want to use two parameters now to construct my table. I say tooth, tabulate it with the SOP, the mode of delivery, and also with the dose. You can see. So for the 0.5 milligram, for under it we have the orange juice, we have 10. The vitamin C, we have 10. Under 1.0 milligram, the same thing. Under 2.0 milligram, the same thing. If your own data set may not, most likely might not be this exactly, and if it is this, then it's not bar charts that is needed to plot anything. Well, that you need to plot anything at all, because bar chart is just to show the frequency of the various parameters you are working on. So just note that. So let me come up here, let me save the dose frequency table, contingency table as those, and that of the delivery method, let me save it as SOP, and that's combine the two of them together. Now let me see it as SOP dose. So I said those, or just note, say those table, so that you are not confused. Those table tooth, those. That's it. It has no need that when I talk about those table now, that is what you are going to use for me. Let me say SOP table tooth SOP. Now SOP those table for me, SOP, and then those. Okay, for me to now plot my bar charts, I just say the function for plotting bar chart is bar plots. So say bar plots and enter my table streets. I just say those table to give me the bar chart for table. You can see it. Now alternatively, if you are good, you have known how, you don't need to be saving and all the right, can still do same bar plots table into what now? Tooth those. You are still going to get the same thing. Now for us to know whether, okay, you see it, still the same thing you are going to get, exactly the same thing. There is no change. Okay, let's see, we want to add main, that's title, just say those bar plots. I want to add X lab, just say those in what? In milligram per kilogram body weight. Any other thing I want to add? That's how I'll add all that, and it will work it out for me there. Okay, let's go enter. You can see those bar plots, those this, and it's giving me what I want there. Okay, what else should I want to show you again? The same thing, the same way. If you want to use our bar plot for the sub those together. Okay, I didn't save that one this way. Okay, let's say bar plots. We save it as sub table. That's what you save it as. Or we say alternatively you can just use table into what now? Tools, your dollar sign, then the sub. Okay, let's check this. You can see what is giving us. It is giving us that. Let's add title to it. I don't need to be adding title anymore. Now you know how to add title. Bar plots of delivery method. Delivery method. So you can play around with all that. If you want to add color to it, you can add color. Anything you want to do, you can do. Okay, so let's assume we want to add color to it. Bar plots. Need of me repeating all this. Just you can put your Y lab frequency if you like, or number of peaks. Yes, number of peaks. Say my X lab is you are talking about delivery method here. Say X lab delivery method, color, concatenates, that is join two things together. I want to see dark blue and orange. You can see, so we are using two different colors. You can see it there. What I've also used are call equals to what? Rainbow length, our sub those, and you're good to go. To give you different color, you can specify black, specify whatever color you want to specify. So that's how we do that. And let's assume that the type of bar plots you want to plot, you want to join two things together, like we did using sub those. We said we can say bar plots sub those table main my plots color. Just use let me just go up there rather than choosing everything again. So just go back, bar plot for me now, sub those table, sub those table. So you give me that. You see, because I didn't specify whether it should be stack or this thing, you see what will happen now. He layered it upon each other. He stacked them upon each other. Let's assume what I don't want it to be on top of each other like this. I want it to be beside each other. What do? I will just specify beside equals true. You can see it. Mind you, like I said, because of this data set is not meant to be, or bar plot is not the best way to present this data. That's why we are seeing it like this. If it's your own data that bar plot is presented, you see this will be higher than this, or this could be higher than that, and you can compare and contrast two things together. Okay, so let's go to another thing now. Let's with what we have done, I believe you are good to go in terms of bar plots. If you want to do this one, you have it in the scripts with you already, so you can see just the same thing that we have done up there. All these one are things you can do now based on what we have done. From here now you can see that the different flowers we are presenting here, you can see them here, and there's no big deal about that one. Okay, let's come here now. Let's see box plot. Box plot is a fantastic chart that gives you an overview, a quick overview of your data graphically. If you are good at analyzing box plots, with box plots, just looking at it, you can get a lot of information at the at the snap. Instantly you get that. It give you the range, the maximum, the mean, talk about the minimum, the mean, the standard deviation. If there are outliers, you can see them easily. Okay, let's check this out. We talked about tooth before. We know we understand when I'm talking about tooth. That's the experiment that was conducted to look at the effect of vitamin C on the length of odontoblast at various doses and at different using different delivery method. Okay, let me say box plots now. To plot your box plots, you just specify the function, which is box plot. Then will give us the particular field you want to plot. So you subsect. The field you want to plot is the length, because for box plot, definitely you are talking about a numeric variable, not a character, string, or ordinal and all the no. You talk about numerical variable. So there is the length. That is the length of the odontoblast. Look at it. From here, easily we can see this black line at the middle. That's the mean of our value. That's the mean of our value. And we can see the highest value. Look at the minimum value. We can see if there were to be outliers, we can see them here. We can see plus or minus our standard deviation there instantly. Okay, let's assume here we want to put color into to just make it a bit colorful. Say blue. You can see we have blue there. Let's put notch. At this middle. We want something just all these are just beautifying things and just working things, making things a little bit appealing. Say notch, yes, put it through. Now the border, let it make it brown. Make it brown. Oh yeah, let's go. You can see looking at this, a lot of things giving you insight quickly. Let's assume that we saved this. You can also save it as B or as anything. If you do this, for example, I'm just going to explain some things that I've written so that if you see them in your notes, you are not confused. If you want to, if I was to do this will not echo. Let me change the color here so that you will see that what I'm plotting here is different from what I've plotted before. So you will not see the brown anymore. So if I enter something like this, it not be you will not see it most time instantly. It will store it in the B. So when I now output my B, you can see output my B now. It will give me various information now. Initially, when we just plotted it straight, output it, it just give us the bar plot. It didn't display all this information for us. But now we want to get this further information. We just first of all store the box plots into a particular variable, and now we echo or we print that variable. Now display this to us. What is telling us? It's telling us that we have 60 observations. 60 observations that were used in this data sets, and the confidence, the minimum in terms of the first quotile, third quotile is between 16 and 21. Here, this is the minimum value that you have in that data set, and this is the maximum value you have in that data set. If you look at this, this should be the what do you call it now? The 25% to the 25 percentile. 25% of them are at least of these. Then this should be 75 percentile. 75 percentile. Why this is the median? This is the median. So instantly, and all these are shown here graphically. They are shown here graphically. Like this 4.2. This is it here. That's what you have here. This 12.55. That's this here. That's this place. This 19. That's this notch here. This 25.35. That's it here. And this 33.9. That is what you have here. So now, if there were outlier, it will show us, but we don't have any outlier. We don't have any outlier. That's why it's giving us 0. If there were outlier, it will show us the outlier where it is and the group where it belongs to. Because we could have gotten multiple groups here. It will tell us the groups where the outliers are and their names. Okay, so that is it about box plots. So box plots is something great that you can easily get things from. Now let's let's merge a data together. I want to use box plot to see how the length depends on the delivery method of vitamin C. Does the delivery method of vitamin C has any part to play in the length of odontoblast? No. Without, so that you understand more, let me plot it here. I'll say box plots line. I've told us in the class how we get this tilde sign. You press shifts, there is a sign before 1. There is a key before 1 on your keyboard. You have that particular key, then 1, 2, 3, 4, 5, like that. So if you press shift and that key before 1, you get what I've shown you, what you have now on your key on the screen. So this depends on sub. What data am I using? I said the data I'm using is tooth. Right, I could have said tooth. Let me use that also so that you see what I'm saying. I say tooth so that you are not confused. Tooth length dependent on tooth sub. You can see it. But I don't want to be typing too much, so I can save myself typing two times. So I can just say the length of odontoblast dependent on sub the data I want used is tooth. Okay, I want you to add color for me. Let the color be orange. I said I want the X lab to be named method of delivery. And I want the Y lab to be named length of odontoblast, or length of teeth, anyone you like, odontoblast. The other parameters I can specify, you can see there what is given me now. That's shown me you know, the box plots for the orange juice and the box plot for that of vitamin C direct. It has shown me that. So you can play around with all these other code here. When you run this, you can see, in case you want to change it, you want to invert your data sets, your plots, you do this. All these are just the same thing. I'm just playing around with data set here. The same thing, the way you did that of the supplementary, the method of delivery. You can also do that of vitamin C. That is the dose. Then we can use, a range of colors like we did before using rainbow. I say, okay, I want to use 3 colors from rainbow. I declared it. Okay, it's calls. Then I put all these here. I told it I want to see how the length of the teeth of odontoblast depends on those and on the delivery method together. I want to look at it together. So I just specify here. This is just to ensure that there's a space. You can see I say 1, 2, 3. I say 4. Silent. No. Now say 5, 6, 7. You will see what that is doing later. You will give a space in between the 3 data sets, the 3 box plots that will be coming up. I say S lab equals this, Y lab equals that, then the main, then the color now. I said equals calls. I didn't want to type all these inside here. That's why I first of all declared it here. This is just for you to understand that you can declare something and later recall it, just like we do in mathematics. Say recall. In those of us that do further mathematics, and even in mathematics, when you say x equals this and that, you start solving, and I say recall that this equals to this. Now substitute that. So that's what we're doing here. Okay, now let's plot this. Now let's run it. You can see now, if you observe, you can see this is like 1, 2, 3. Look at here now. 4 could have been here, but this is empty. It's empty. So this is 5, 6, 7. So if I didn't specify that now, if I didn't put that place, definitely this one will start from here. We start from here. So that's just the essence of that. I can remove it, but just to make our graph more presentable and easy, a little bit readable, more than when it's clumped together. That's why that was done. Maybe we will end this video here now. In the subsequent class, I will talk about the various statistical analysis that we can perform. Thank you for your time. God bless you.